So hi guys, welcome again to another video, and for this video I'll be summarizing the chapter 7, which is the IP address. So sorry for my voice because I have cough and my voice is very low. So let's start. We have here the binary and decimal conversion. So to convert this binary IPv4 address to decimal, we will just enter a 8-bit binary number of each octet under the positional value of row number 1, then calculate to produce the decimal. So here, it's just easy because if the binary number has number 1 and it focuses on the positional value given, so we'll just add the binary number that has value of 1 and we will add their positional value just like the same in the decimal and binary. We'll just find the appropriate answer and then we'll put their binary number. So for the next one, we have the local AND. So for the local AND is one of the 3 basic binary operators in digital logic. So it is used to determine the network address, and the logical AND of 2 bits yields the following result: 1 and 1 equals 1, 0 and 1 equals 0, 0 and 0 equals 0, 1 and 0 equals 0. So for the next one, we have the network host and portions. So here IPv4 is hierarchical and it composed of network portion and host portion. So all the devices on the same network must have the identical network portion. So the subnet mask helps the device to identify the network portion and the host portion. And this, what I'm explaining to you, is for the IPv4 address structure. And for the next one, we have the subnet mask, and we have the 3 IP addresses must be configured on a host. First, the unique IPv4 address of the host. Second one, the subnet mask identifies the network or host portion of the IPv4 address. And for the next one, we have the default gateway, which is the IP address of the local router interface. So for the next one, we have the prefix length. This is a shorthand method expressing the subnet mask. So equal the number of bits in subnet mask is set to 1 and written with a slash notation followed by the number of network bits. So let's proceed to the unicast transmission, multicast transmission, and for the broadcast. So just like in this full course, the unicast, multicast, and broadcast has the same meaning about with each other. So for the unicast, we have 1-to-1, and for the multicast, we have 1-to-2, and for the broadcast, we have 1-to-many or 1-to-all. So let's proceed. Here we, just like what I've said, just sends one data to one, and here it receives it gives the data to all, and this one, not all, will receive the data. So let's proceed to the classless addressing. So in this graph, it has a different class. So the classful system allocated 50% of the available IPv4 addresses to 128 Class A networks. So 25% of the addresses to Class B, then Class C shared the remaining 25% with Class D and E. So the problem is that wasted a great deal of addresses and exhausted the availability of IPv4 address, and not all organizations' requirements fits well into one of these three classes. So for example, a company that had a network with hosts of 260, and you need to be given the Class B address with more than 65,000 addresses, wasting 64,740 addresses. So classful addressing was abandoned in the late 1990s. So for the newer and current classless addressing system, however, there are still classful remnants in network today. So let's proceed to the next one. We have the dual stack, the tunneling, and the translation. So this is for the IPv4 and IPv6 coexistence. So for the dual stack, devices run both IPv4 and IPv6 protocol stacks simultaneously. And for the tunneling, we have the IPv6 packet is encapsulated inside the IPv4 packet. And for the translation, we have the network address translation, or the NAT64, and it allows IPv4 and IPv6 enabled device to communicate with IPv4 devices. So that's all for this video. Thank you for watching. See you again on the next video.